Aloha and welcome to our video on the theory of plate tectonics. We'll explain the theory of plate tectonics. We'll also talk about different types of boundaries, and then we'll talk about how these plates are moving around. Okay, so let's talk about the theory of plate tectonics. The theory of plate tectonics is kind of unique because it's one of the few theories that we can actually see how it changed over time and developed. It's a young idea. One of the neat things is it took a bunch of different ideas and blended them together to make it into one unifying idea. And that's the unifying idea that we use for earth science. Now, plate tectonics took the idea of crustal plates from Alfred Wegener and that continents move and these plates move, and looked at the evidence of seafloor spreading and came up with a mechanism for how all of this works. And that's what made this theory so believable and makes it so that currently that's how we think the earth works. Now we can see that we have all these different plates and you can see them on our map here. And notice that these plates are where there's trenches that we talked about, and also where we found these mid-Atlantic ridge and other ridges that we've talked about. So we found that there were borders to these plates, and in doing so, we could also see where they were moving. And we noticed that where we had the mid-oceanic ridge, and you can see it right here, that this plate was moving, or the plates were moving away from each other there. And that's what we would expect with seafloor spreading. We also noticed that we had plates that were moving into other plates, and that's where we had subduction and things of that going. So these ideas that we had from seafloor spreading led us to believe that we can look, and here's the actually spreading, and we can see where South America is moving away from Africa, and that kind of showed us what Wegener was trying to say. So the Earth's crust is broken into plates. These plates are actually moving, and we have evidence to show this. So because the Earth's crust is made up of all these different plates, these plates have to interact in areas. And we call this area of interaction a boundary. And there's only so many different kinds of boundaries we can have. And we're going to go through those real quickly. But before we do, I want to show them to you real fast. Now, we can have two plates that are moving apart from each other. And this is what we call a divergent boundary. And we'll see that one in this slide. We can have plates that are coming together, so they're going into each other, and we call those convergent boundaries, and we'll cover those next. And then we can have plates that aren't moving towards or away from each other, they're kind of moving side to side. And those are what we call transform boundaries, and we'll talk about those last. So let's start with our divergent boundary. Divergent means that they're moving away from each other, and that's what the arrows are showing us, that we have this plate moving in this direction, and this plate's moving in that direction. And as the plates move away from each other, they create this gap. And in this gap is where we see magma rise up and we form new mountains, new material, new crustal materials. Now, we can have rift valleys on land or in the ocean. In the ocean is where we have our mid-Atlantic ridges. There's a rift valley in East Africa, which is pretty popular. And that's where you can see the continent is actually being ripped apart because it's on two separate plates. So divergent boundaries, we see the plates moving apart from each other, and we see the formation of new material. Okay, so let's talk about convergent boundaries. Now, convergent boundaries are where we have two plates and they are moving towards each other. They're crashing into each other. And these are going to be distinguished based upon the type of crustal plates that are interacting. So in this case, we have an oceanic crust, which you can see here, and then we have our continental crust, which is going to be over here. Now, the oceanic crust is going to be more dense. It's going to be a little bit denser than the continental crust. And because of that, where these two collide, this oceanic crust is being forced under the continental crust. And that's in an area we call a subduction zone. And where these crusts are being pushed under is where we see our trenches. We have these oceanic trenches. Now, as this oceanic crust is being forced down into the mantle, it'll melt away. And as it melts, we see new magma forming, and that new magma is going to rise up, and we get these continental volcanic arcs. So you can see that these volcanoes are going to form a ways away from where the plates are actually interacting. There's a distance here, and that's because that's where that plate's being forced under and melting. So an oceanic and a continental crustal convergent boundary we generally will find a trench, which is a deep part in the ocean, and you can kind of see that here. And then a lot of times we'll find this continental volcanic arc. So those are the clues that we would look for that this is happening. Now, if we have oceanic and oceanic crust, it's an oceanic convergent boundary, we're still going to see the same types of things. We have oceanic crust over here, and we're going to have oceanic crust here, and we're going to have this subduction zone again, and one of the plates is going to slide under the other, and as that happens, we're going to see another trench. These trenches are where we get our really deep trenches. Now notice that this plate over here has some oceanic crust to it, and then ultimately it also forms some continental here. So we can have both on the same plate. They don't have to be one or the other. Now, once again, this oceanic crust is being subducted. It's going to melt, and we get this magma come up, and we're going to see this volcanic activity. But here, notice it's not on the continental crust. So what we end up with is a volcanic island arc. And things like the Philippines or Japan or Indonesia are going to be these volcanic island arcs that we can see around the world. The Aleutian Islands would be another good example of this. Now we can also have continental convergent boundaries. And what we see is we have continental crust here and continental crust here, and they're migrating together. And at one point there might have been some oceanic which got forced under, and we had a little volcanic activity. But this one I like to think of more of as a car wreck. And what happens is we have a really good example where we have the Asia plate up here, and then we have the India plate as well. And the India plate is traveling into and slammed into the Asia plate and caused this great collision, and that collision was the Himalayan mountains. And that's where we find Mount Everest. So while these two plates are hitting, instead of one subducting under the other, they just kind of buckle and are upward thrust a little bit, and that's how we get these really high mountain ranges like the Himalayas. Now in this picture we have our transform fault, and that one's going to be a little bit different. In the previous examples at Divergent, we had new material being made. At the Convergent, we're kind of losing crustal material. And at the Transform Boundaries, we're not having any at all. There's just the same things. These plates, as you can see, are just going to be moving past each other. So there's no subduction here. It's just going to create a fault, and we'll talk about that a little bit more. But what these plates are doing is they're kind of sliding past each other, and that's what we call a transform fault boundary. So Wegener's big flaw was he didn't have a mechanism for how these big pieces of the Earth could move around. And what we found is that the core has some uneven heating, and that's going to cause a mantle to have some uneven heating, and we get these plumes of heat. And you can see one of them over here, and you can see one that's all the way up here. And as that plume of heat comes up, it's going to hit and create these currents. So as I'm moving upwards, I'm going to create this current. You can see that we have mantle material moving this way. It's going to hit the crust, then it's going to spin. It's going to cool off, come back down, heat up again, and it's going to go around. And we get these huge currents, these convection currents going in the mantle. Now, as this convection current here, we'll just blow this part up right over here. We have this convection current of mantle coming across this way, and it's going to be moving in this direction. The crustal plate that we see above it isn't going to be smooth on the bottom. It's going to be kind of jagged and uneven and all like this. And as it's sitting there with this current moving, it's going to push this crust in this direction. So what we notice is that's what's going to drive these plates moving. When these plumes come up, we're going to have areas where that plume's going to arise, and it's going to come up and split and go this way, and we have two separate things, and that's where we're going to have our divergent boundaries, where these two are going to be forced away from each other. And if they're forced away here, then this one here is going to bump into another one, and we could have our convergent boundary right over here. And if there's another plate that's lying next to it, that's where we can get our transform. So these mantle convection currents is what's pushing these plates around, and that's why we have plate tectonics. Okay, so that's it for the video. As always, this was just a real quick overview of it. You'll get a lot more from going through the lesson. Good luck on the quiz, and we'll see you in the next video.